talk about angular difference. Angular difference. Now, the angular difference between two places is the angle subtended at the center of a great circle, of a great or small circle, by the minor arc formed from joining the two places on the great or small circle, respectively. Again, the angular difference between two places is the angle subtended at the center of a great or small circle by the minor arc formed from joining the two places on the great or small circle, respectively. So if you see this diagram here, angular difference is simply saying what is the difference in, difference in latitudes, being represented by this phi, this symbol phi. So the angle here, phi, is the difference in the latitudes here. Latitudes are coming from, moving north-south, while your longitudes here, you have this lambda, this symbol, is this angle here. The difference is simply saying what's the difference in longitude. Your longitudes are running east or west, left to right. So longitudes run left to right, or what to say, east to west, while your latitudes run north-south. So what is the difference in that latitude? That's called the angular difference, phi here. And what's the difference in longitude? That's called angular difference, lambda here. So these symbols could be anything. We use theta, we could use whatever, we use alpha, beta, all those Greek Latin symbols. So let's continue. So there's a mnemonic for calculating angular differences. If two places are in the same hemisphere, if the two places are in the same hemisphere, then subtract their different longitudes or latitude values. What do we mean? Now, okay, we'll continue, I'll explain what that means later on. Now let's look at this diagram, for instance. Example 1, find the angular difference between the points E, which is on these coordinates, and point F, which is on these coordinates. Find the angular difference between the points E, which is on 45 degrees north, as you can see in the diagram, and 90 degrees west, and point F, which is on latitude 30 degrees south and longitude 9 degrees west. So if you look at this diagram of the Earth, let's call this up here above the equator, we'll call it northern hemisphere, and below the equator here, we'll call it southern hemisphere. Let's look at it like that. Northern hemisphere above the equator, southern hemisphere above the equator line. Okay, so how are we going to find the angular difference between these points E and point F? So from the diagram, you can see that they are on the same, they are in different hemispheres. Point E is in the northern hemisphere. It's above the equator, the northern hemisphere. And point F, which is actually this point here, is on the southern hemisphere, right? Okay, so how are we going to find it? Let's go back to our mnemonic, which is a device which helps us to remember important facts. Okay, if two places are in the same hemisphere, then subtract their different longitude or latitude values. But if the two places are in different hemispheres, then add up their different longitude or latitude values. So we have a mnemonic DD. You can see difference and add. So D is common to both words. Different start with D, and add has D in it. So that means DD. So if they're different, you add up. So let's go to that question, example 1, and we'll add up their different longitudes. Add up their different longitudes or latitude values. So what is different? You add it up. See, they have the same longitude, 90, 90. They have the same longitude, 90, 90. So we are going to only add up what is different. What's different here, guys? You can see different latitude of 45 degrees north for point E and different latitude of 30 degrees south for point F. So if they are different, we add it up. If they are different, we add it up. So we're going to add 45 to 30 degrees to get the angular difference. Look at, this is angular difference, this angle. To move from equator at this point up to this point, you've traveled 45 degrees, and to move from equator down to this point, you've traveled 30 degrees. So basically, you just add up to different values and you get the angular difference. So point E is in the northern hemisphere, as I said, and point F is in the southern hemisphere. For different hemispheres, add up. They are different values. So whatever is different for them, you add it up. Hence, angular difference between 2 points, between the points E and F, is equals to 45 degrees plus 30 degrees, which gives us 75 degrees. Yes. Yes. So let's look at an example. Find the angular difference between towns B on these coordinates and town C on these coordinates. So town B, you can see town B. Town B is on 40 degrees north, 35 degrees east. Now, 40 degrees north is on this. This is the line. This is the cross section or the diameter of the parallel of longitude 40 degrees north. You see, this is 40 degrees north, right? This one is equator. This is equator circle, and this is the latitude 40 degrees north circle. So B is on this latitude 40 degrees north, and C is also on 40 degrees north, but they are on different longitudes. So you see, B is on this longitude 35, and this is 50 degrees. So this 35 degrees east longitude, and longitude 50 degrees east. So B is here and C is here. B is where? Here, and C is this point. So this dot is for B, point B or town B, sorry, and this point here represents town C. Okay, so how are we going to find the angular difference? So what do you observe? Are they in the same hemisphere? Yes, they are in the same hemisphere, northern hemisphere. They are up north. Notice it's down south. Okay, they are up north. Okay, so that is, you just simply going to add for different longitudes. See, they're on the same hemisphere. For the same hemisphere, let's go back to our mnemonic. What does our mnemonic tell us? Two places on the same hemisphere, subtract their different longitude or latitude values. So they have different longitude values. So in the same hemisphere, we subtract. The same hemisphere, you subtract. SS, the same, subtract. Same, subtract. Okay, so let's go to that. Okay, so the same hemisphere, not. And so we subtract. What's different in them? What is the different values? Is the longitude. So we subtract. It will give us 50 minus 35. And so the angular difference is 50 minus 35, which gives us 15 degrees. 15 degrees. Okay. Okay, let's go to the next subtopic. Great circle distances. What do we mean by great circle distances? This is the length of the minor arc measured along a great circle. This is the length of the minor arc measured along a great circle. That is a longitude or the equator. What I mean is that a great circle is either a longitude or the equator. Notice those are the only great circles we have. Okay. For example, in the diagram, you have a distance along PQ. You see, the great circle distance, say you are traveling from point P to Q. See, you are traveling along that equator circle. You are traveling along that equator line. Notice your equator, right? Or it could also be along a longitude. See, from our definition, a longitude. So point P to point Q is traveling along this longitude, right? It's traveling along this longitude. Okay, so from P to Q, it's traveling along this. So that's a great circle distance. Guys, that's what we call a great circle distance. Either along the equator, distance PQ or arc PQ, or along the longitude, this particular longitude colored in red. So distance PQ or arc PQ. Remember, this longitude is part of a circle, so we are calling this an arc. yes, that subtends this angular difference. So you see your knowledge of angular difference comes in handy here. So this arc is what we're calling a great circle distance, or this one also, great circle distance, which has this angular difference also. All right, come along guys, let's continue. So the formula length of an arc from senior maths, length of an arc is given by theta over 360 degrees times 2 pi r. The length of an arc is given by theta divided by 360 degrees times 2 pi r. So your theta in this case is your angular difference, and the arrow in this formula is the radius of the earth. Okay, the radius of the earth. Okay, for great circle distances. Okay, so theta is the angular difference. Okay, so let's continue. How about small circle distances? How about small circle distances? Small circle distance, this is the length of the minor arc. For small circle distances, this is the length of the minor arc measured along a small circle. Just like the name says, small circle distances. So we are going to be looking at the length of the minor arc, because the minor arc is simply the shorter arc. Notice the minor arc. The other going round will be a major or longer arc distance, but we're interested in a minor arc, because pilots want to travel the shortest distance. So we'll consider the minor arc instead of going from G. You want to go from point G to point Q. It's not cost effective to travel like this along the major arc. No, this is a longer distance. So we're considering only the minor arc, just from G to Q direct along the minor arc, right? So remember that this latitude, is not like the equator. The equator is a great circle, but this is a smaller circle. You can see it's a smaller circle. This latitude is a smaller circle compared to the equator. So it's called a small circle distance. This arc G to Q, distance GQ, which we are calling an arc because that is the arc. This is the arc part of a circle. Okay, you can see, okay, radius here, so on and so forth. Okay, so in the diagram we have distance along arc GQ and not arc PA. So arc PA is not a small circle distance. The distance PA, or the length of arc PA, is not a small circle distance because it's along the equator. The equator is not a small circle. It is a great circle. Remember, the equator is the only latitude that is a great circle. That is, has the radius of 6,400 kilometers, which is roughly the radius of the Earth. Okay, so arc PA is not a small circle distance. Okay, so let's continue, guys. And so our length of arc formula, we have a little modification. So it's the same theta over 360 degrees times 2 pi arrow, but our arrow this time is going to be capital letter R cos alpha. R being the radius of the Earth, but it will be a smaller length, so it will be cos alpha. So the R radius of the Earth cos alpha. So this alpha is the value of latitude. We are traveling along a small circle latitude. So what's the value of that latitude? That will be our alpha. It will be our alpha in this case. So for your inquiries and home tutorials, you can call Petroscience Tutors on that number, or visit Petroscience Tutors on Facebook.